Okay, today we're talking about the relationship between a radius and a chord. And so there are two things that I need you to know. All right, the first one is if a radius, let me see if
I can look.
if a radius bisects a chord, then it's perpendicular to the chord. All right, and the other thing I want you to know is just the backwards of that. So if a radius is perpendicular to a chord, then it bisects the chord. Okay, so those are the two big ideas for the day. And let's just talk about why that would be. So let's talk about this first one, the blue one. It says if a radius bisects a chord, that means this is the radius and it bisects the chord. Why would it be perpendicular to the chord? What you could do, if this is a radius, we could draw in these two radii. And then we've created a triangle over here and a triangle over here. So what that would do is it would force this to be congruent, this to be congruent because radii are congruent, and this is reflexive. So if you're looking at these triangles, and that would mean that these two triangles are congruent, which would force this angle right here to be congruent to that angle right there because they are corresponding. So that being said, if those two angles are congruent and they're a linear pair, it forces them to both be right angles. All right, so that's the reasoning behind it. It's not just like some, magic that's happening there. So let's talk a little bit about the other situation. Again, here a radius this time says it's perpendicular and then it bisects. So if we have it being perpendicular, again, if we draw in the radii, we've created two triangles. We know these radii are congruent, and we know we have this reflexive side. So this triangle on the left would be congruent to the triangle on the right by hypotenuse leg. You have a right triangle, then you have the hypotenuse is congruent to this hypotenuse, and this leg is obviously congruent to itself. So if that's being said, these small triangles are congruent to each other, so their corresponding parts have to be congruent, which would force this to be congruent to this, and then therefore this radii bisects the big chord if it's perpendicular and makes these two things congruent. So that's the reasoning behind why these two statements work, and they're the statements we're going to use today.